Hey guys, this is day 4 of Advent of Code 2025, and in this problem we're given 2D grids that look like this. For each position there's either an @ symbol or just a period, and the @ symbols here are described as rolls of paper, right? So there's a whole story here that you can read if you want to, but basically there's either a roll or there's no roll. And in part 1 here we're trying to find the positions where there's a roll and there are fewer than 4 rolls of paper in the 8 adjacent positions, right? So all the positions surrounding a given position. All right, let's have a look at the input that we're given. So this is what the file looks like here on the right. So I think we have 135 lines, and each line has 135 characters. And so I've written a bit of Python to pre-process the input here. So yeah, 135 by 135, and this is the first line of the file on the right-hand side here. And then I have just written a function here to check on the neighbors of a given position. So R is row, C is column, and the function returns the number of roles, roll neighbors, I guess, right? And so this function will help us solve the problem here. So given this, it's fairly easy to just go through the whole grid and count up the positions that that have fewer than 4 roll neighbors. So let's do that here. So we're going to go through every row and column. So for R in, let's see, range length of grid, and then for C, which stands for column, in range length of grid 0, we're going to create a count variable here, and we're going to check the condition, right? So if count neighbors of grid and then RC is less than 4, then we're going to increment our counter. We also need to check, I guess, if there is a roll at that particular position, right? Because that's what they want in the problem. If grid RC equals this symbol, only then do we increment the counter. And then I'm going to print what we've been counting here, and that's the answer to part 1. Now for part 2, they want us to count how many rolls with fewer than 4 neighbors can be removed, meaning replaced with a period. And so as soon as we start removing some, that'll free up others to be removed as well. So we're going to have to do this iteratively. So I'll start with a while true, and then create a change variable to keep track of how many rolls we've removed in one iteration. So I'm going to copy and paste this guy. So for each position in the grid, if we have fewer than 4 neighbors and grid RC is the @ symbol, then we want to remove it, meaning replace it with a period. So grid RC equal to period, and we're going to increment change to indicate a removal. And then we want also to keep track of our total change. Change equals 0, and then total change plus equal to change. And then if ever change is 0, that means there aren't any more to be removed. So we can break out of our while true loop, and I'll just print out the final result here, which should be the answer to our problem. Yeah, so that's it for part 2. So you see here it took 0.4 seconds to run this cell. So to speed this up a bit, we could put this condition first. So I'm going to put that here because that's faster to check than evaluating this count neighbors function. And in that case, I'm going to run all, and okay, it's 0.1 seconds instead of 0.4, so that's a bit of an improvement there. If we want to see what the grid looks like at the end after removing all the ones that can be removed, we can do that just for fun. So let's print out the grid. So for our in grid, I'm going to do print join of R like that, and then we can see, well, let me zoom out here. So on the right, this is what it looked like before all the removals, right? And then on the left is what it looks like after we removed everything that can be removed. And so for each roll here, you expect to find at least 4 neighbors, right? So you can just verify that visually, right? And it makes sense that these clusters would be left over here like this. It's kind of cool to look at, but also kind of random. So anyway, thanks for watching. Hope that was helpful, and see you in the next video.